Peldon. This is Math 155. This is Chapter 3, Section 4, Exponential Logarithm Equations. Since we did Section 3 on all the simplification techniques, now we know how to do those. We can actually solve equations. Okay. So in the first one, we have a base 2. So what do you use to cancel a base 2? Well, the whole premise of the chapter is to use logs, right? Because normally you wouldn't be able to solve this with your standard solving techniques. So we'll use log base 2 of 2 to the 3x minus 8 equals log base 2 to the 16, which of course a base 2 log cancels a base 2 power. So I'm left with 3x minus 8 on the left side. And this is log base 2 and 16 is 2 to the 4th power, which will also nicely cancel. They move 3x minus 8 equals 4. We'll add 8 and get 12. Divide by 3, x equals 4. You can plug that back into yourself to prove it that it actually works, because 3 times 4 is 12. Minus 8 is 4. 2 to the 4th is, in fact, 16. Okay, we'll go to the next one. We have 27 and 9. Well, if I do 27, it won't cancel the 9. If I do the 9, it doesn't cancel 27. So you should look for a common base, and 27 and 9 have a common base of 3. So this is 3 to the 3rd power. And this is 3 to the 2nd power. And if you simplify using basic exponent techniques of power to power, which is multiply, you get 3 to the 3x plus 3 and 3 to the 2x minus 2 when we multiply using the power to power rule. Now we have a common base of 3, so I'll do log base 3 and log base 3. Because what you do to one side of the equation, you must do to the other if you're solving. The first one we simplified, but this one we're solving in this step, so they can't now cancel, because log bases and power bases cancel their inverse operation. So you have 3x plus 3 equals 2x minus 2. We'll subtract 2x, and we'll subtract 3. So that means x plus 0 equals 0 minus 5. So x equals negative 5. That should work out okay. Oh, we got a mistake. That is a 9, actually. That is a 9. That is a 9. So minus 9, minus 9. So that's actually 11. Sorry. Just caught that really quick on myself here. Minus 9, 11, and 11. There we go. Perfect. Okay, let's move this up. Try the next two. You still do have to follow the order of operations backward when solving equations. This is a factoring scenario. So in C here, you have to do the order of operations. So they do add, subtract step first. So we have 40 e to the 0.6x equals 240. Then do the multiply divide step. Divide by 40. So e to the 0.6x. Let's see, that would be 6. Okay, so then we have to do the exponent radical step. Well, we have to cancel an e. Well, what cancels an e? Log base e. What's log base e? Natural log. So natural log of 0.6x equals the natural log of 6. So that'll cancel, leaving me with 0.6x equals the natural log of 6. So typically the last step would be grouping symbols, right? But this is actually in a grouping symbol, because anything in an exponent isn't a understood parentheses, kind of like anything under a square root is in parentheses, which is understood. So we'll divide by a 0.6. So x equals the natural log of 6 divided by 6/10. And that is our answer for x here. Okay, so this is an isolation technique where you just have a singular x you have to solve for, just using the typical solving strategies, except you have to add in the log, which is something new. This one, of course, is multiple x powers. So this is not an isolation. This is factoring. We have to do factoring technique. So your standard quad form factoring, e to the x times e to the x will give you the first term. So this is 1 times 3, which is a positive 3, which is either 1 times 3, negative 1 times negative 3. Well, I need to get a negative 4 from the middle term, so it must be this one. So they multiply a positive 3, but they add to the negative 4. So e to the x minus 1 equals 0, and e to the x minus 3 equals 0. So e to the x equals 1, and e to the x equals 3. So again, you need to get rid of the e. Well, we just talked about this in the previous section. What cancels base e? Log base e, which is the natural log. Okay, so that gives me x equals the natural log of 1. Remember, the log of 1 is always 0, no matter what the log is. And this will give me x equals the natural log of 3. So we're good there. Okay, last one, we'll move it up a little bit. We have plenty of room all the way across and underneath. So we have two different bases, 5 and 4. So you remember in the first one, we only had one base. We just did a log of that base. In the second problem, we had two different bases, but each of them could be broken up into common bases. But 5 is prime, and 4 is just 2 and 2. So there is no common base here. So basically, pick one. Does it matter which one you pick? No. I'm going to pick the left-hand side one. So log base 5 of 5 to the x minus 2. Get rid of that little typo there. And log base 5 to the 4 to the 2x plus 3. Again, the premise here is what you do to one side of the equation, you do the other, right? So that cancels on the left side. So I'm left with x minus 2 equals log base 5 of this stuff. But I can use the power rule to bring down the 2x plus 3. So it's going to bring that down using the power rule times log base 5 of 4. Okay, so I'm going to distribute this log into the parentheses. So I get x minus 2 equals 2x times log base 5 of 4 plus 3 times log base 5 of 4. So the question is, why did I distribute? I need to get the x by itself, so I have an x term on both sides. So I'm going to add the 2 to the other side and subtract the 2x term to the other side. So what does that look like? So on the left side, I'm left with x in minus 2x of log base 5 of 4. And on the right side, since those went away and those went away, I'm left with 3, that line went a little squirrely there, log base 5 of 4 plus 2. So now logs on one, x is on one side. I can factor out an x and be left with 1 minus 2 times the log base 5 of 4 equals 3 times the log base 5 of 4 plus 2. So that gives me my final step now, which I divide by that stuff. So I get my final answer of x equals 3 times the log base 5 of 4 plus 2 over, what do we have here? 1 minus 2 times the log base 5 of 4. I think that's it. All right, pause the video. Try the student problems. All right, student problems. The first problem only has a base 5, so we'll do log base 5. Oh, I wrote a 3. Fix that. So that's 5 to the 3x minus 6. And that's log base 5. We know 125 is 5 to the third. Okay, so cancel, cancel. 3x minus 6 equals cancel, cancel 3. So we'll add 6, and we get 3x equals 9. Divide by 3, x equals 3. And we're good. All right, next one, 8 and 4, they don't match. But they have a common factor of 2, though, because that's 2 to the third. And that's 2 to the second. So now I can simplify and get 2, 3x plus 6. We'll mess up my distributing this time like I did last time. Okay, so I think we're good. Now we can use log base 2 on both sides. Log base 2 of 2 to the 3x minus 6. And log base 2 to the 2 to the 2x minus 6. Cancel, 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 cancel. 3x minus 6 equals 2x minus 6. So if I move things over now, I get x, add 6 equals 0. Ooh, typo. Oh, that was a plus 6 there, I'm sorry. So therefore that must be a minus 6. So my final answer is negative 12. Okay, sorry. All right, next one. So we have 1x here, isolation strategy, move backwards, add subtract step in the order of operation comes first when you go backwards. 7e to the 2x equals 63. And multiply divide step. Divide by 7. E to the 2x equals, we got 1, 9. Okay, so do the exponent radical. So canceling e, we'll use natural log of e to the 2x equals natural log of 9. So cancels 2x equals the natural log of 9. But again, when you're under a square root or something like that, or in an exponent, there is an assumed parentheses. So that gives us my grouping symbol, which is my last step. Divide by 2. X equals the natural log of 9 divided by 2. Okay, last one is multiple x's. That's a factoring problem. So quad form factoring. E to the x times e to the x gives me e to the 2x. 1 times 7 gives me 7, which is 1 times 7, negative 1 times negative 7. But I'm going to need the double negative because that multiplies to 7 but adds to negative 8. So e to the x minus 1 equals 0. E to the x minus 7 equals 0. So e to the x equals 1 or e to the x equals 7. We need to use natural log. Cancel, cancel. I get the natural log of 7. Cancel, cancel. X equals, remember, natural log of 1 or natural log of, or any log of 1 is 0. That's our two answers. All right, scroll down. We'll do the last one. So this one is the devil's choice because you can't use anything that'll cancel either one. We have multiple logs. One's prime, so it does have no factors of the other than 1. So choose one. Doesn't matter. We use 3 or 7. I'll choose to use 3. So log base 3 of 3 to the 2x minus 1 and log base 3 of 7 to the x plus 1. Cancels there. So I have 2x minus 1. I'm going to bring the power down using the power rule. So x plus 1 times log base 3 of 7. The parentheses are very important because the x and the 1 are being multiplied by that log. So I'll distribute now. I'll get 2x minus 1 equals log base 3 of 7 times x plus log base 3 of 7. And you can put the 1 in front if you want, because this log essentially went to both of these. So there is a 1 there, although you don't really need it because it's 1 times the log. I'm just going to get rid of it for simplicity's sakes. So now I need all of the x terms on one side, so I'm going to add 1 to that side. Oops. Whoops. And then I'll move the x term over to the other. So that'll give me, let's see, 2x equals, sorry, minus log base 3 of 7 times x equals log base 3 of 7 plus 1. Essentially, we're subtracting that to the other side is what happened. Trying to save some room here. Need to get the x out of there by factoring it out. So if I factor out an x, I'd be left with 2 minus log base 3 of 7 equals log base 3 of 7 plus 1. We'll divide by that constant term we no longer need. So our final answer, after those cancel, log base 3 of 7 plus 1, which is just some constant number, and divided by 2 minus the log base 3 of 7. And there is our final answer. That is the end of part 1.